All right, so I hope everybody's doing well. I'm not doing so well so far, but it's gonna be the last lecture for today, and then when we come back on Thursday, that would be the final exam review. Um, and after that, we're gonna have a certain things. So after that, we're gonna have the final exam. So remember that the final exam will be on next Thursday, so that will be on May 14th. So this is the time where we're gonna take the final exam. And again, that there will be 24 hours. You're gonna have like 300 minutes to complete them. So how can we find a final exam? So it's literally going to be there. You're gonna check the questions, and of course you're not gonna see test two and submit test two. You're gonna have the final exam and submit the final exam work for the next folder. So I do not plan on collecting the final exams solutions because I know that we have a lot of things to take care of at the end of the semester. We have like classes, we have certain things. So the quizzes and I have no idea. I think did I mention that we have a quiz? So I'm gonna change the quiz question so it should be today. I project for that. I'm planning out a little bit too early for this. So the quiz number 5 would be on May, would be tonight. So you can start it from 7:30 tonight up to, I'm sorry, it should be 8 because I haven't really have that. I'm gonna post the quiz there, and then the end will be on Wednesday, 8 p.m. So this is the time that we're gonna take the quiz number 5. And after that, we no longer have quizzes. So all we need to do was literally going to have a quiz solutions. I'm going to post solution. Did I post solution on quizzes? I don't think so. So I post solution for all quizzes and all the classwork. So I do not accept any classwork right now, but I believe today is going to be the last day that we're going to submit them. Okay, please try to do so. All the classwork submission for May 5th, and after that I'm going to post solutions with the solution for the final exam review. So the final exam review is literally where's the final exam review? I don't see any of them. Yeah, so this is the thing that we have for all the questions, and just practice as much as you can so that we can deal with that. And how many questions are going to be on the final exam? So I would say it would be pretty much the same thing as second exam that we just took. And you can basically see how many questions out there. The focus will be on a little material, so there'll be more point on chapter 7 up to chapter 14. So we skip chapter 13 and we skip chapter 10. I mean, we did not skip chapter 10, but we did not really go into the detail how we're going to figure out the analysis for that. So I believe we're going to work through the project. So that will be the finish for chapter, the project part 3. So you can submit it. So what day for the submissions for the project? I would say will be due. I didn't really check the due date generally, but it should be due a few days after the final exam. So I did not put down a due date. Yeah, I did. So that'll be due on 16. Okay. And I will so 4 points, so I'm going to change that to May 15th. I'm going to make it like 18th for that part, so you can submit a project by May
Did you
18th.
say May 18th?
Yeah, so we can have more time
Okay, thank you.
for the project part 3. I mean, don't try to do though. Like don't try to do some before the final. Some people actually did really well in the project, but they failed final exam. I mean, final is 40%. So this is project is 4%. I mean, this part, so this is only 1/10 of the grade.
When are we doing the review questions for the exam?
That'll be next. That'll be on Thursday.
No, I'm saying, are you collecting review questions?
No, I'm not gonna collect. I'm
Okay.
not gonna collect them.
All right, thanks.
Unless you want to do though. If you want to do all the review of the final exam questions, I can help you check them out.
All right.
And send me pictures, or I got a person's last semester. I mean, not last semester, a few semesters ago, and she did every single problem from the homework problem. So let's say we look at the homework problem, you see how many questions are there, and she did all of them. To be completely honest, she did every single one of this, around 25 for each chapter, and you can see how many problems that she did. And of course, she got an A, but I don't want you guys to spend too much time working on a problem, because I know the fact that we have to take care of the other courses. But what I'm saying is that we still have to finish the project by May 18. So that should be more than 2 weeks, right? I believe that most of you finished the second questions of the project. It was literally coming from chapter 10. And then when we test out the analysis, I'm going to post the sample project for that part as well, for those of you who can complete them. For the project part 1 and part 2, so for those of you who still have not finished, I will give you some time to finish it. So everything will be due on May 18. So if you want to resubmit your project, the answer is yes. If you want to resubmit it, but you need to let me know, email me. And for that part, so let's say I resubmit it, I want my project to be regraded, and I would do them. But you need to let me know, because usually once you submit it, this is the grade that you have. So I don't know if you already submitted or not submitting it. And so that is going to be a very troublesome issue for me, right? And for the classwork, this is the thing that I really want to point it out. There will be 15 classwork for the entire semester, right? All of this is going to be the homework questions for that part, the homework grade, 5%, plus 5 point with the classwork that we have on the extension review. So the total will be 20. I know I still do not have time to look at it, so I'm very busy preparing the final exam. So I will look it up. I will answer your question over the weekend. So this is the thing that I usually, if you want to take the if you retake the exam, then you have to apply for it. You go to the chair, you apply for it, and then you're gonna wait a certain time to take it. But I know the outbreak is coming, and I got two people who got sick. Of course, I cannot let you know who they are. I mean, not only two, but for this class, two, another class with another two people. So I completely understand that we are under a lot of issues and very, very hard circumstance. But you still have to take the final exam. There's no makeup for the final exam. If you really want to make up for the final exam, so let's say you can't take it, right? So if you take the final, that will be a grade. You can't tell me that, well, I took the final exam, I didn't feel so good, then I'm not going to do it. So there's no point of doing that. The only thing that we can do for this part is that if you feel sick on that day, right? So you don't want to take the final exam. So once you postpone it, for example, that I have to take care of my family members, whatever the reason is, you have to give me a certain. I would say it's really hard to get a doctor notes now, but usually that you need to plan on. We're taking a final exam at the end of January, so that should be on January 27th. You would say that'll be 2 months from today, and I'm not sure how much that we can remember. So please try your best to take the final exam in May 14. So after the final exam, you can submit a project, or you can submit earlier if you can finish it. And that's basically the thing that we need to take care of. And after that, there's no more thing that we have to do. There's only one concern when you grade your classwork. I have the file unread. Some of the people who submit a file with a different format, so I cannot read it. So I pointed out, so you look it up in your grade. If you sort of like see some classwork that is unreadable, you have to let me know so I can regrade. Or you have to change format. You have to resubmit and email me saying that I resubmit my classwork. Because once I grade classwork that I feel like I cannot read them, I basically put some notes on the grade so you can check that. And you submit it and let me know. You have to let me know because I don't know. I don't know if you resubmit or not. So I cannot keep track of it every single day. And so finally, for those of you who miss, again, for those of you who started quiz, right? Quiz number 5 did not really put on. I think I forgot it. To be completely honest, on that day I was a little bit tired. So the quiz number 5 is a little there, but you need to redo them. It's not going to be the same files. I'm going to get rid of this. Okay, so I'm going to get rid of that one, and I replace by a new file. So please check the work around 9 p.m. So we're going to have until 9 p.m. Tomorrow to submit the quizzes. When you start, you have an hour and 30 minutes to finish it. So I can keep track of the people who actually do the quiz. And finally, the lecture notes, and I actually put the lecture note right there. So for those of you, I think I stopped putting there from April 23rd, I apologize. So the lecture note should be available, so that'll be on Tuesday, Monday, so all of that. So you can click on it. So let's say you were sick, you didn't pay a lot of attention for that part, so you can check them. So this is the note, they can see through it, and then you can work on it. And each lecture note, they have a certain problem. So this is the thing that we have on the class, right? On the Zoom courses, so we can check them out for the lecture notes. And besides that, we have the documents for each chapter. So every single chapter they have a chapter summary. What else that can I do? I believe I did not prove anything in this class, which is a sad part of it. Because we need to understand there's no way to can understand statistics from scratch because it requires a lot of profound knowledge in math and calculus and statistics. So we literally have no idea how to prove that the area under the normal curve will be exactly 1. We have no idea how people came up with the probability model such that the z-score between -1 and 2 will be, we just use a table to figure it out. And for those of you who are interested in knowing those, just email me. I have the proof for that for chapter 12, chapter 11, and why we're going to use the chi-square for the variance estimations or standard deviations estimation. I mean, in terms of population variance and population standard deviation. And why we're going to use this, why we're going to use the chi-square to test on the proportions, which is called the good enough fit, and how we're going to use the chi-square for independent test. So I didn't prove anything. I just literally, okay, I see the gap. I just want to make sure if the gap is not big enough, then we say we cannot disprove it. As simple as that. So the fact is we can't prove anything. The only thing that we can do in statistics is we try to disprove the wrong thing, try to get rid of as many things as possible to maintain a goal. When it comes to the chapter 14, this is also a very important chapter. If you study time series model, if you study the machine learning or artificial intelligence, what do you think about all of this stuff, right? So how can a robot can predict the human behavior, can imitate the human behavior? It's literally a learning method that we have to predict the move of a certain things that we see. But it's a very, very complicated problem that the statistician, they try to work with the neural system, right? So how the brain functions so that the robot can predict them. So that's going to be a very dangerous move for a human being to have a robotic intelligence developed during the day. But it's, of course, this is we cannot prevent them happening. So this is really important. So this is going to be the predictions of the data set as well, right? So the reason why we want to know the prediction is want to see what model that fits to a certain data set. So this is what the regression analysis is going. So when it comes to chapter 14, so what we have to do, let's say I'm going to give you a bunch of data sets, right? And let's say we have like the data set go like this, right? So this is what we call the bimodal. So we have two peak on the data sets, right? Bimodal. And when the data set's going like this, and for example, let's go like this, a bimodal is, it can be polynomial functions. So it's go like this, the data set is go like this. There's only one peak for that part, right? And this is basically the normal curve, right? And it's just like when we try to predict the cases generally, and it's going up and down for that point. So this is what we call the normal distributions, right? When the curve is going like this polynomial, and it's go like this, okay? And go up again, for example, so this is the parabola. So what we're trying to predict was we're trying to put down a certain model that work for the data set, right? A simple set. When we have a certain model, so this is the model that we actually do it. So this is what we call it the linear model. And this is basically the most important model. So let's say the data sets go like this, right? And then we can sketch a straight line that fits all of these data sets. So we call the linear regressions. Okay, as simple as that. Let me just repeat that again. What is the regression model? The linear regression model is a model that fit all the points, right? It's a linear model that fit all the points, all the data set point. That fits all the data set point. So what's so important about this is what is the line? How can we figure out this line, right? So some of you want to be asking me, how can we do with the Excel model that can come up with the line relatively easy, right? So they just do it because it was a long time model that we did. Excel can do it in 2 seconds, right? And other statistical package that can do it in a few seconds as well. And the line, so what is the definition for that line? Is that there's no way that we can get the perfect line that matches all of this point unless it's going to be the curve that will predict them. So the prediction statistic is literally, I'm going to find the line regressions, which is y equal to ax plus b, right? That will minimize all of this point right? All of the distance between that. So plus b. So that fit, the word fit is literally minimizing all the distances. So the statistician, they're trying to get the line, right? So the distance, so we're trying to figure the line with the slope and then the y-intercept that fit all of this point with the minimized distance, right? So if this, so we can, if I can find a line that going to give me the least error of the distance, so that line is gonna be a regression line, not this one. So the regression line is literally the replications of a line that can fit all the data set point with the minimized error. Okay, the minimized distance. So I did prove them, but not in this class, in the calculus-based statistics. And most of the students, they also figure out it's really hard to do so, right? So let's say how can you draw the distance between one line? So let's say I want to figure out, hey, what is the slope and what is the y-intercept that can fit all of this point? So let's say you're gonna get x1, y1, x2, y2, x3, y3, and then we can compute the distance between this line and the point and using math, right? And then we differentiate it, you set them up equal to 0, and after that, we're gonna solve for this. I mean, it's not gonna be a very, very hard proof, but again, it requires a lot of profile mathematical background, especially in calculus point perspective. So that's the reason why we don't do this step. So the linear model is literally the model that we call the best fitted model, or which is called the least square models. Okay, so usually when you read the book in the future, for those of you who really want to take statistics, you're gonna have the keyword least square. Why we call it least square? So the least square meaning that we find a line that minimizes all of these points. This is a very basics, but this also be the most important one. So for example, let's say any model can be transformed to a linear. So for example, we have a polynomial model. So we're gonna have like a equal to ax squared, polynomial ax to the n, for example, plus a0, an, whatever. So it should be an, and we're gonna get, those are the, for example, the constant. So n raised to the n minus 1, right? And so on and so forth. If you can't find me the polynomial like that, right? So that can fit all these points. You sort of feel like, all right, polynomial looks like the perfect model, right? Polynomial. And you know what the polynomial function looks like? It's just a combination of the different power of the x. And we call it polynomial model. So what the statistician they do is that I can actually take the log. When I take the log of y, for example, right? If you study math, and I can't just take the log for each of them, so we can become the sum of the log of that we call the ln. So ln is exponential log. I'm sorry, the natural log for that. And so to the ai and x to the I, x to the n, or x to the I, for example. So we have the power for that. So what's going on about this guy is that when we take the log, and so we can bring down a power. So this I can be putting down, become I times log of aix. So that becomes the log linear. So in other words, log linear pretty much have the same characteristics coming from the linear regression. So this is what I call the log linear model, or log linear regressions. So it still be a linear model. So that's the reason why this model is really, really important when it comes to a different perspective for that part. So so that's perhaps the reason why the least square model, I mean the linear model, is the first chapter of any statistic or stochastic statistics process, what kind of process that we study. So this would be the thing that we need to understand. So how can people actually figure it out? We learned the fact that the correlations and the covariance was something that we learned in the past. And so the very important thing that we should understand is that the covariance is between A and B, right? So between the bunch of data set, the covariance, we call it COV. So that would be the sum of xi's minus x bar. So remember, x bar and y bar would be the unbiased estimators, meaning that it's always be on a line, and yi minus y bar, right? And I think that we learned it from chapter 3, but you don't have to worry about that on the final exam. So this is just something that we want to see. So it should be divided by n, but since that we always dealing with the sample covariance or the sample sample correlation, so we always use the word n minus 1. So this is the sample covariance. Okay, so for that part, so we know the fact that this determined the thing that we have earlier, saying if they move in the same direction, if the data set moves in the same direction when x increases, y increases, when x decreases, y decreases. So this is what we call the positive correlations, where the lines go straight upward from the left to the right. So this is what we call positive because all of these data set hold the same relationship, right? So when x increases, that we can literally check when x increases from x1 up to x2, right? And you can see that the y also increases a little bit. So it's going upward. So that's going to generate the positive sample covariance as well. So when it comes to the correlations R, and I know most of you actually learn it. So what can we do? How can we solve for the correlations? That we're going to take the covariance, right? And over the standard deviation of x times the standard deviation of y. So this is basically like a 2 dimensions, right? 2-dimension correlation. It's not going to be a thing that we need to deal with that. So what's happening, some people ask me, how can we develop the model that include not only for x and y, it can be x1, x2, x3, x4, x5. So the linear regression model can be a multi-dimension regression model. But for 2-dimension, this is the thing that we should care about, right? And after we develop the R, so what is the R? The R is literally the thing that we look at it, and then we can justify if the model have a strong or the weak correlation. So the R sometimes is not good enough, and people in mathematics or in statistician, they also prove that R should be bounded between 1 and -1. So what does it mean by that? Is that the correlation should be less than or equal to 1, as simple as that. So we can take the absolute values of that, and that should be less than or equal to 1. So you cannot have any relationship that is greater than 1 for sure. It's always less than 1, 100%. So when R equal to 1, meaning that they have the perfect linear regression model, meaning that each value of x is going to match with each value of each value of y on the same regression model. Yeah, this is what we call statistics, right? So when a lot of you might have a little confusion. What is the difference between maths and statistics? Some of you might be asking me saying, well, I mean, math is literally, so this is what we call math, right? So the math is the most hated object. Math is very painful for most of you, including myself. I'm kidding for that. So even if I do not study a lot of conceptual math, but it still be a very, very logical topic. But the reason why math is somewhat difficult because it's so dry and then we don't know how we're going to use them, right? So I talked to one of the students in Cal 2, and then he or she basically have no idea why we have to study all this calculus point and so on and so forth, unless we see some integrations, some application along the way. So the math is literally the thing that we have. So math is going to give us a function, let's say 2x plus 1, right? So, and after that, we're going to do what? We're going to make a chart, for example. So this is from math 103, I believe. I'm not sure. All right, so you're going to give me some point 0, and you're going to get 1. If x equal to 1, then we're going to get 3, I'm sorry. Yeah, and if you give me x equal to 100, I can plug that in to solve for y. So let's say you give me x equal to 100, plug that in, so that'll be 200 plus 1, that'll be 201. Right, so this is what we call the map, and then we can sketch it on the model. And so I apologize for that part. And all we need to do in this case was, okay, so when x equal to 0, y equal to 1, x equal to 1, y equal to 3, and so on and so forth. And this is the model that we're looking for. Okay. It doesn't seem to be a good model. Let me just resketch it. Right? Yeah. So this is what we call the y equal to 2x plus 1. So why is so important to differentiate between math and statistics? Because they seem to be different topic, but they actually not different topics. So what statistic looks like? So statistic is here, right? What a statistic looks like? I'm gonna give you like a bunch of data sets. And then we're gonna have x and y. And you might have like x equal to 0, y equal to 3, x equal to 5, y equal to 10, x equal to 4, y equal to 8, x equal to 6, y equal to 15, x equal to 1, and y equal to 2, for example, right? So you can have a lot of points. So if you, the difference between math and statistics is that the math, they basically generate a model. And then we use that to reapply it to the statistics. Okay, so this is what the map looks like. So you give me the model, I can get the point. In statistics, you give me the points, I'm gonna generate a model. So this is what we call statistics. So the thing that we're going to put them there, of course, we're not gonna have enough space to do so. In this case, that we're gonna have x0, y equal to 3, x equal to 5, y equal to 10, and x equal to 4, y equal to 8, and x equal to 6, y equal to 15, and x equal to 1, y equal to 2. And for example, so those are the points. So our job is literally look for the line that best fits of this point, right? We don't know what direction of that is, but as long as it's minimized all the distance for that. So this is the line that we're looking for. Okay, in statistics. So this is y equal to, I don't know what it is, y equal to ax plus b. So let's say I want to do it in Excel, for example. Let me just go to this one real quick. And let me just go to Excel. So again, this is what we can get it done relatively quickly for that part. For example, that I want like a certain point. So I want to generate a model for this. So let's say we have 0 and 3, right? 0 for x0, 5, 4, 6, 1. So 0, 5, 4, 6, 1. And for the y values that we can have 3, 10, 8, 15, and 2. 3, 10, 8, 15, and 2. So this is x and this is y. And apparently all we need to do, we just go to insert. And yeah, this is literally a thing that we need to do on the project as well. And then you just go to a scatter plot. So we can see that this scatter plot the purple chart for this part. And so this is what we have for the linear model. It's very straightforward. I can check them. So it doesn't look like linear, but what is the line that gonna fit all of this? So I go to the chart elements, and then I click on a trend line, right? I click on a trend line. So exponential, it doesn't look like exponential. There are some forecasts as well, but we're not gonna learn it, right? So let's say we go to more options. Now, I mean, it looks more like the exponential model, but we only deal with the linear. So we're gonna set the intercept. I'm sorry, we're not gonna set the intercept. We're gonna display the equation on a chart, and then the R square. So this is the thing that we need to do, right? So what the function looks like. So this is the model that I would say between X and Y, and then I can solve for the regressions relatively easy by just box those data sets and go to Excel. I mean, it's not easy as just go to Excel and code. We need to compute all of that. We can do it by hand, but we skip that part because it's not going to be on a final exam. I do not want you guys to learn how to compute them. It's going to be a very, very long story unless you insist on learning that. So what does that mean about these values? So the y equal to ax plus b generated from this data set, right? Unlike map, I give you model, you give me x and y. For the statistic, I give you x and y, I give you a data set, and then you help me generate a model. So they work opposite, but of course they have a very strong connection between them. Map is making the model for us, like probability. So the line that we're looking for will be y equal to 1.9552x, right? 1.9552x and plus 1.3433. 1.3433. So this is what we call the slope, right? So the slope basically the value that go with the x, right? So what does slope mean to us? When x increased by 1, the y more likely to increase by 1.9552. I mean, almost double, right? And then this guy that we call the y-intercept. Why we use this is this is the y-intercept because this is the constant, and this is where the line started with. So they started from 1.3, 0.433. It's just a point right there. Okay. So this is the line that we had generated, but you want to see how valid, how validity, but we're not going to analyze it unless we take to a certain perspective, to a certain level of the statistics. So some of the statistics on chapter 15 that we test on their correlation. So we want to see if the line are going to have a very strong correlation or going to have a very weak correlation. So in this case, we have the R squared equal to 0.9051. It's generated from the system. So the R squared that I'm going to have. So what is the R squared? The R squared is basically the same as the small r squared that we learned earlier. So the R will be the correlation. So let's say R equal to 0.99. So that would be very strong correlations. It's very rare that you're going to see a data set that have the correlations equal to 1. That's impossible because you can't officially find a true data set that matches on the same line. It doesn't make any sense. So they should have some point and that going away from the regression. So that should be normal to have the R not equal to 1. So when you take the square, will be equal to the R square that we have here. So the R squared that we have on the regressions is 0.9051. So what does this number tell you? 0.9051, for example, right? So some of you might be asking what this number is going to give us a certain thing. So when you take the square root, so if I take the square root of 0.9051, we're gonna have 0.95. So that is a very strong correlation, meaning that we have a strongly positive correlations between x and y in this example. So that would be 0.951367. So in other words, they have a strong correlation, but what does this number tells us, right? What does this number going to indicate? So this 90.9051 is going to tell us that 90%, 90.51% of the data set. I mean, we only have about 5 data sets, so that's not going to be a big deal. But when you are dealing with a really big data set, like a sample data set, it still have require like maybe around 50 data. So what does that mean to us? So the R square basically indicates, so you're going to answer this with this question of project. The 90.51% of the data sets of the data are involving in the statistics. Okay, involving meaning that they're setting up the equation. So all the data sets, so 90.51% of data sets are involving in this regression model, which is y equal to 1.9552, x plus 1.3433. Okay, involving in the regression model, right? So meaning that that is a good, data set. So around less than 10% of data set are not involving in this regression model. I mean, that was a pretty good balance, right? So we have a very strong correlation, to be completely honest, in the regression model. That was pretty good. So so for those of you who are working on the statistics, if you set up the exponential model, that we can do so, or any model that we have. So we look for the R square and to see whether or not it's going to make this increases or decreases. So let's say I developed the exponential model. I got the R square equal to 0.95, for example, instead of 0.90. So meaning that the exponential model predicted more relevant than the linear model. So I'm not saying that exponential is better, but its prediction is more relevant compared to the regression model, as simple as that, because of that involving 95%. For this example, that we're going to have 90%. So in this case, I would say what's going on for that? I would say I'm using the x. I'm using the x to predict the y. So when I'm using the x to predict the y, we call x as independent variables. So why we call independence? Because the value for the x does not depend on the y, right? So when you set up this equation, so let's say I plug in y equal to 5 using the regression model. Let me just use calculator since I don't have one. I mean, I do have one, but what I'm saying, you can see them on that example. So let me just do so for that part. So okay, I can use 2 or 3, doesn't matter. Okay, so coming to that example, let's say we have let's say I use x equal to 5. Okay, so let's say I plug in x equal to 5 into this line. I'm gonna get when x equal to 5. What's going on for this part is I plug that in, so we're gonna get y equal to I'm not gonna do it by hand, so it take me so long to do so. Y equal to 1.9552 times 5, right? And plus 1.3433. So this is a thing that you have to be responsible for on the final exam. Let's say I give you a certain value of x, then we need to solve for y. If you know the regression model and what it looks like, and then you solve for that. So if I want to do it on a calculator, I'm going to get 1.9552 times 5 plus 1.3433. So the answer for that is 11.1193. So what does that number telling us? So this is going to be 11 point, I'm sorry, 1193. Right. So this value is different from the actual value for the y, right? So the actual value for the y is when x equal to 5, right? When x equal to 5, then I'm going to get the y equal to 10, correct? So this is what we have the matching value for this, right? So this is what we call the actual value. So the actual values that we don't, the actual value is when x equal to 5, y equal to 10. But this is the y in this case that we cannot use the y by itself. Usually that you have to rewrite the equation with the y hat, right? It's different. The y hat will be called the predicted value. So the predicted values is the values that based upon the regressions. It's different from the actual value. So the actual value was the value that we collect the data set from, right? So we collect the data set from sources and from Google, Yahoo Finance, whatever it is. But the predicted value should be different from the actual value because the predicted value is the value that coming from the regressions, right? Coming from this line. So let's say we have x equal to 5, y equal to 10, right? I feel like it's really important to know, even if it's not going to be on the final exam. So this is what we call the predictive values. Since my model doesn't look so good, meaning I can't use this model, so I believe, and then I post this for that part. And I'm gonna post right here. So when x equal to 5, right? And so this is the actual value. So let me just draw that so I can see it. You can see it immediately, right? So this is what we call the actual values, right? The actual values that we have is 10, right? So when x equal to 5, y equal to 10, correct? But this is what we call the predicted values right here. It should be slightly above. And so the value that we got is, this is a 10 for y, but this value coming from the line equal to 11.1193. So this should be different, right? So you can see the predicted value are not the same as the actual values, right? But what's so good about that is it might be slightly different because of compared to the actual value, but this is going to give us a relatively good options. And how the most important thing is how we're going to see the 10s deviate from 11.1193. That is the more important thing. So the gap that we have, we still have the gap right there. So similarly, when we have x equal to 6, I can have the value for 6 will be equal to 15. But when I use the line, so it'll be 1.9552 times 6 plus 1.3433. So that'd be 13, right? It's not going to be 15 if we have on the model because this point is slightly off, like a big gap between the actual values and the predicted value. So in this case, that we can check this basically equal to 13.07, right? So this is 13.07. So 13.0, I'm sorry, I forgot that. 0.07, yeah, 45. So we can see the difference. So the most statistician they really want to test how valid of the line going to be when it predict using the 5-point analysis. So we have 5 points. So this is a thing, right? So so in other words, our job is going to determine the R square was basically, so we know what the R square stands for, is basically tells us how many percent of the data sets are involving in the regression model, right? And in that percentage, there's percentile as well. So we can take that notion. But the most important thing is I think I got rid of. The most important thing is we want to see how much different between the active values and the predicted values. So what's going on for that part? Yeah, you can read this model. I'm not gonna read it, but this is what we can tell between the point and the predicted value. So this is what I just pointed out from the pictures. Um, so the difference. So let's say this is the difference. So let's say in this case, the point that we have the value for y equal to 15, right? The actual value. So when x equal to 6, y equal to 15. So this is the actual values, right? And so the predicted value that we got is coming from the regressions that we just computed on the calculator. So 13.07. So all of these values, so I'm not really good at sketching all of that, to be completely honest. I apologize. So so all these values, the gap between those, so this is what we call, so we're going to take the square. Why do you have to square? Because there will be some point above and some point under. When you add up the gap, you're usually going to get 0 for sure. So what's going on for this part is we're going to get the y minus y hat square, right? So y minus y hat square will be called, I don't have no space, so I can just move it right there. So I apologize for that. So I should put it down. Again, that I do not have enough space for this part, so I'm gonna move my finger, my things right there. So the y hat a y. So the y would be the actual values minus the y hat, which is called the predicted values, right? And and then you square them. We squared it. So we do not want to avoid. I got rid of all of this letter on that cell, unfortunately, and this is what we call the unexplained variation. So this is the thing that we deal with in statistics. Okay, unexplained variations. Why we call unexplained? Because we can't explain it. This is actually the difference between a data set and the regression model. It generated by the intrinsic value. So it just, when you study the risk, similarly, we have systematic risk and unsystematic risk, right? So systematic risk can be found and rearranged and actually control, but unsystematic risk would be the risk that we can't control. It's coming from the data set, different value for this part. It might be affected by external factors, right? So there will be certain things that's happening to this question as well. So in this case, we call the this is what we call the SSE, would be called unexplained variations. So this is a thing that we should know. Unexplained variation. Variations. So what does that stand for? So that would be the square difference between each data set values and the thing that we have. So there will be another difference. So let's say we compute the x bar and the y bar. And so we can literally check that the x bar, so we can do the x bar and y bar in this case. So the x bar would be the average for all of this, right? No name. Okay. So and then the y bar would be the average for all of this. So we can see that the x bar and y bar are relatively the thing that we have. So the x bar is 3.2 and then the y bar is 7.6. So when we come back to the model that we have, where's the model? Okay, so the x bar that we have found is 3.2 and 7.6. It should be that one, right? So remember, the X bar and Y bar should be on the line. Why it would be on the line? Because we have proved this. We didn't prove that, but we have indicated that the X bar and Y bar are unexplained, unbiased estimator, so that have to be on the line. So now also the difference between this, the distance for that part, and the point is right there. So this is from this to the X bar. So from the active values, which is that one, from the actual from the Y hat and the Y. So we call this guy as I forgot the ed. So this is what we call the explained variations. So why we call this as the explained variation? It can be controlled. It can be explained by the intrinsic value in this case, so it has nothing to do with the actual value that we have. This is just the regression errors that's generated from the linear regression at that specific point when x equal to 6. So this will be the y bar minus the y and square. I'm not sure if I write them down correctly. And so it should be, I'm sorry, y hat minus y, I'm sorry with that. Y hat minus y bar. Right, so you can see the different, so the y hat is right here, right? The predicted values minus the y bar. The y bar is just right there, 7.6, whatever it is. And so these values that we call SSR. And so since I don't have a very good handwriting, so I'm gonna just type it instead of writing down. So SSE, that we call the unexplained variations, and SSR, that we call the explained variations. So this guy we call explained variations. Okay. So I forgot, I missed the ed in this part, and yeah. So this is what we have for that part. So for total variations, so total variations would be the difference, the total variation that we learned from chapter 3, right? So we learned the fact that how can we compute the deviation? So we want to take the difference, right? So we learned from chapter 3 that we're going to take the difference. So the point that we have is here, right? So the difference between the x and the x. So in this case, so the difference between the y and then the y bar. So this is what we call the total deviations. And then we put the square for all of that, right? So to indicate what? To indicate this is the total deviation for this. So remember that how can we compute the sample standard deviation? Then you have to take each data set, right? We subtract the x bar. So in this case, we take the each y data set, we subtract the y bar. So this is what we call the deviations, or in other words, that'll be the total deviations. So if you don't know how to do this one, then you're gonna fail to compute a standard deviation for that part. You have to take each data set minus the sample mean, and then you square them, and then you add them up, and then we divide it by n minus 1, take the square root, right? So all of this we call the deviation.
Sorry, is this for the is this project 3?
No, this is for chapter 15. Finding.
Oh my god. Okay.
No, I mean, this is the thing that we learned from chapter 3. The deviation that we learn is taking, so this is the each data set value minus the y bar, and then the square. So I'm going to take one specific point. I take when x equals to 6 and y equal to 15.
So
okay?
in the exam, we have to know how to do this.
Yeah, but not any calculation specifically. If you want to do calculations, let me know. I actually have the whole file to do so, but you don't have to do that. But just to understand what it is. And when we compute a standard deviation, then we have to take the sum for that, right? So the sum that we have, when we take the sum, and when we take the sum, we call a total deviation for that part. Again, that we do not do it explicitly, especially when it comes to the formulas. So the sum for the total variations will be y minus y bar, right? Something that we learned it from chapter 3, and then you square them, we divide it by n minus 1, we take the square root, we got a sample standard deviation, we look like a king because we sort of feel like we got what happening on chapter 3. And we break it down in terms of the sum of the two. The sum of the two, so that will be started from y minus y hat would be the predicted value on the regressions, and plus the sum of the y hat minus y bar, right?
In regards to like this type of questioning, is a question like this on like is a question related to this on the final exam review packet?
Yeah.
Okay, great. Okay, thank you. Also, side question. I probably missed it. Do we have class on Thursday?
We do.
Okay, great. Okay, thank you.
And for that part, we're gonna have this one we call SST, right? SST will be the total variations, and equal to so this guy we call unexplained variation, so that would be SSE. Okay, SSE. So you can see the picture clearly. This is what we call the unexplained variation. You can see that the difference between 15 and 13.07, just square them, we do every single point like that. So we call unexplained variation. So we can see that. So this is the thing. I draw out a line. I draw out a line for that. So this is what we call unexplained variations. And yeah, so different between that for each point, right? So we call this is unexplained variations. Okay. So I feel like, oops. Okay. So so generally this is the thing that generated from the data set. So it's coming from the nature of the data set. So for the y values compared to the predicted values, so we can't control it. We can't explain it. So for that part, we have the SSR, right? So what is the SSR will be called different between the data sets and the the difference between the predicted and the y bar. So we call the this guy we call the explained variation.
Okay, hold on.
Yeah.
Oh, sorry. I didn't know my mic was on.
Oh, you don't know your mind's on anyway. So for that part, and that's pretty much the thing that we need to do. And how people compute the R square based upon that is, again, those, in order to prove that it's not hard. So the R square that can be computed using the covariance, right? And then over the standard deviations of X and over the standard deviation of Y, and then we can do so. So in this case, in order to generate the R square, I just divide both sides by SST, and we're going to get that part. When I divide it by SST, what's going on for that? So the R squared is basically equal to explained variations over the total variations. So I'm not going to draw out anything like that. So I'm going to copy and paste. Just want to be fast. And that's pretty much the thing that we need to do. So in other words, I'm going to copy and paste for that part. You need to be responsible for what it is. So the R square would be the explained variations over the total variations. And so we can utilize this to compute it, right? So if I divide everything by, we're not trying to prove that, but we can prove it very easily when we look at the covariance and standard deviation, but since the part. So I just divide both sides by this, right? By SST. So we do it for three sides. I'm sorry, for both sides, right? So we know the fact that this guy is R squared, right? So by doing so, I can subtract. So this is SST over SST is 1, and equal to SSE over SST plus R squared. So we can figure out the R squared equal to 1 minus SSE over SST. Okay, as simple as that. Either way is fine. Usually on the exam that we can do it both way, which is perfectly all right when you do it that. So we gotta be really careful. So the R square going to see how much data set going to be explained. We're going to be involved in the regression model, in this model, because we already set up the regression model. So that's the reason why we have the R square, right? So that's really important that we justify the R square will be the ratio. The R square should be less than 1. So there's no way that you can have something that greater than 1, because we know the fact that SST is part of it, and take 1 minus something's positive should be less than 1, right? So we're making sure that R less than 1, when you square a number, should be less than 1. You can't not square a number that is smaller than 1, and then the answer is bigger than 1. That doesn't make sense. Okay, so so the R square is how much data set going to be explained, right? Coming from the regression model. So that's a reason why we can think of it. The R square would be the ratio between explained variations over the total variations. The unexplained one is we're trying to minimize as much as we can, but there's no way that we can do so, because it's just the intrinsic value when you figure out the line that is already there. So we cannot like change, when we change the line, the slope of the line, we set different intercepts for that part, you're gonna make all of this different. Okay, so that doesn't work. The only thing that, the second thing that I really want to tell you is that if I take the y as the x and x at the y, for example, so this is the thing that you have to be really careful when you do on a project. So for example, interchange x and y, right? So you sort of feel like, can I solve for x? Can I use, can I solve for x and I rewrite them the regression model? The answer is absolutely no. So if I using this two, and then I generate a different model, for example, it's going to give me completely different, right? It's going to give me completely different model and completely different regression model. So it's really important that we setting up correctly more options for that part. So for example, that we using different line equations. So let's say I don't take x, or I interchange them. So I want to use the y to predict the x. So I interchange x and y, right? So what's going on for this part is that they generate different model for this. So it doesn't make sense when we use the previous model to solve for this model. That's literally not making any sense, right? So we cannot just say, well, I mean, when you treat the x as dependent variables, we come back to this page. The y will be called independent variable. Sorry, dependent variable. So y is deep independent. So the y x is independent. So the y will be dependent variable. So what does it mean by the dependent variable? So all the predicted value of y is literally explained by the value of x, right? Will be predicted by the value of x. So this is what it means by dependent variable. Finally, that we going to have to understand the fact that there's actually no way that we only have the simple regression model, right? So what happened, let's say I want to figure out the income of the persons, so the income of persons, I can also predict the income of the persons by 8 times the educations, right? So sometimes I would say the income has something to do with the education. In fact, it was the negative slope for this part. So some people would argue the higher the education that you have, the less money that you make. I mean, it's not true, but it's partially true depending on what field that we're working on. Sometimes that if you spend like 8 years to get your PhD, for example, and then after that we stop there and then you go out making money, so you might make less money than the people who already work in the industry for a couple of years, and then they actually learn so much from that part, and not to take into account that we owe from the governments and whatever it is. And similarly, I would say I can't just take the B as at the slope for, so after the education, I would say the network, right? So people would always argue saying that the more network that we have, I mean, the better connection that we have, the more likely that we're going to have generate a better income. That is not wrong. To be completely honest, networking is one of the most crucial part that we want to consider as the major part of generating the passive income and so on and so forth. And some people would say, of course, investment. Investment would be something that we would consider, especially when you do not want to leave your money alone. So you want to invest money into a certain field like real estate, stock, Bitcoin, for example, right? So crypto, all kind of things. When you have all of these analysis, and finally, we may want to do the questions with regard to knowledge. So I would say the knowledge is also a very important perspective where, I mean, knowledge is sort of different from education, that it's literally somewhat different because we can study from books and do some research instead of going to school. And then you might end up learning more compared to people who actually work on campus. So, but I mean, they don't have the degree, but knowledge is really important. So sometimes you want to develop the analysis with regard to the EQ or the IQ, whatever you want. So plus dot 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 and plus the constant. So the constant, I would say C. I'm sorry. I cannot use C. I would use alpha plus alpha. Right. So this is the model that we put down. A lot of factor. We take a lot of factor into account. This might give us a better look of what these things relate to the money that people make. So education, network, investment, knowledge, EQ, IQ. I mean, having a good girlfriend, a boyfriend, whatever. So I don't know. So all of this plus the alpha will be the 1%, and this is the constant, right? So what we have right there. So this is the 1%. Okay. And then we're gonna have A1, and I'm gonna get A and B and C and D and F. All of that, we just call the slopes, right? So we're gonna have a lot of slope for this. Okay, so depending on, we have a negative slope and positive slope. So for example, education, they might generate negative slope, meaning that the high education that we have, the less money that we make. Or the networking, it might generate a positive slope, meaning that the more network that we know, I mean, the more people that we know, the better off we are in making money. And similar to the investment, sometimes people put in a lot of investment, but they do not diversify their portfolio, so they're facing a huge risk. So sometimes we don't know. So the investment, it's risky, but it's well worth if we know how to invest them. And the knowledge, of course, is always be the positive to the income, because the more thing that we know, the better that we can make money. So for example, so all of that we call the slope of the regression model. So this regression model generated by 1, 2, 3, 4 different factors. It can be more, it can be 10 different factors for that part, but you gotta be careful when you add in. So let's say you do any statistical report. When you add in a new factor, you gotta make sure if that factor is valid or not valid. Sometimes when you add in a factor, you're gonna make your lines worse instead of better. So you gotta be really careful for that part. But anyhow, it's out of the scope of this lecture, so we're not gonna mention more for that part. So in other words, I can also generate the find the income using different strategy that we have right there. So we call the multi regression model, and so which is called the I use the better instead of A1, A2, so it can have the Y. equal to beta 0 plus beta 1, b1 x plus b2 x2 plus bk xk, and so on and so forth. So this is the regression model for the populations, and this is the regression model for the sample. Okay, so the sample regression model. So usually that people use the sample regression model to predict the population regression model. So you might want to use a certain people income, right? So let's say we form a sample, so you can develop that income relationship, and then we justify this for the entire, let's say, the U.S. population income. So how it's going to correlate it, and but of course it's going to be like a really complicated issue. So we do not do it. Okay, and now we're going to work on a problem. So the problem that this should be on the, I would say work on the final exams review problem. I mean, we do have a problem on the chapter 14, but I feel like it's a little bit too much for that because I still have to cover the last part of chapter of the project part 3. So I don't have time to do so. So the thing that we need to do was the final exam review is right there. So let's work this out. And I'm gonna work through like the last few problems. So I would say I worked through the question number 53. So let's say we have a multiple regression model with the 4 explanatory variables, and then I want to find what is the value for R squared. So remember that we learn it. So the R squared that we have here, the R squared equal to 1 minus SSE over SST, or the R squared can be computed by finding SSR over SST. So either way is going to give us the final answers correctly. But what's going on for that part is that we do not want to waste time. So we want to figure it out of question number 53. So the R squared in this case, right, would be equal to S at 1 minus SST SSE over SST. So that's going to be 1 minus SSE over SST. So the fact that we can, this is question number 53. And so we evaluate this. We can take 1 minus, what is the value that we have right there? So the value is 660 over 1,000. So that'd be 660 over 1,000 divided by 1,000. Okay. And we're gonna do it on calculators, right? So we're gonna take 1 minus 660 over 1,000. So we're gonna get the answers is 0.34, right? As simple as that. Okay. So, and that is the final answers. There's nothing that we can do. So the answers for that is B. Very, very straightforward. There's nothing else that we can do for this part. For 54, now we're gonna go with the 54. And what else for 54? So we can see that the question is asking us to figure out the correlations between X and Y. So the correlation is R. That we know the correlations will be the covariance over the standard deviation of X and divided by the standard deviation of Y, right? And so, so the covariance that we have here for question number 54 is the negative 0.01. So that would be negative 0.01 in this case. Negative 0.01 over, so we don't have the standard deviation, but we have the variance. So we know the variance will be the standard deviation square, and meaning that we're gonna take the square root for 0.25 times the square root of 0.01, right? So we're gonna take the square root of 0.25. I'm not gonna type, I'm not gonna write, and multiply by the square root of 0.01. I mean, if the question gives us the standard deviation straightforward, then we don't really have to do the math. But since the question doesn't give us the calculation straightforward, so we have to do the math for this part. So we're going to take a negative 0.01 over the square root. So we're going to take the square. So if you know the fact that radical 0.25 is 0.05, 0.5 radical 0.01 is 0.1, so it's easy. But if we don't know it, you're going to put it down as 0.25 times 0.01. We close the parenthesis for that, and then we close this one more time. So we're going to get the answers, which is equal to, I'm sorry, make a mistake for that. So negative 0.01 over the square root of 0.25 times 0.01. And the close parenthesis, and I got the answer, which is negative 0.2. So if the question, like remember, if the question gives us the sample standard deviation, then we don't have to take the square root, right? So the reason why we don't have them, because the question gives us the sx squared equal to, I'm sorry, I'm making a mistake right there. S square of x would be equal to 0.25, and x squared of y is 0.01. So we gotta be really careful for that part. And equal to 0.01. Okay, so pretty much we finished this part, and now we're gonna go to the next one. So we're gonna go for the main course of this chapters. So, and now we're gonna go to the next example. So how we're gonna analyze that part. So question number 54. So the manager at the local bank analyzed the salaries and relationship between monthly salaries and hours in the land of X for 30 employees, and the salaries basically in terms of this part. Let me just copy and paste for this pictures, and we can analyze what it is. Okay, so let me just copy and paste for that part. So the salary that we have here will be the things. So in terms of the regression, so I'm gonna put them down right there. So this is question number 55 that we're working on. 55, right? So the salary that we're going to have here. So this is the regression model that we need to write. Okay, so this is the thing that we need to write for that. But the chart going to give us here, and how can we utilize this chart will be a different story. Okay, so I'm going to copy and paste and on this table. So what the question is asking us is that we're going to utilize the coefficient only, so we ignore the rest of them. So since we're not going to deal with that, so I'm going to cross this down. I'm going to cross this down. I'm going to cross this down and cross this down. So the only thing that we're going to look at will be the line equation. So we can write that as salary in this case. So remember, the intercept will be the y-intercept, the surface. So this will be the slope. So I can rewrite the salary equal to 9.19 times the surface, I would call x, right? Plus the 784.92, and plus the error bar. So the error bar that we don't consider it. And so now we're going to have this regression to solve for the question. So what the question is asking us, we need to answer which of the following the monthly salary of an employee has worked for 48 months at the bank. So what we're trying to answer is that we're going to rewrite this. I'm going to plug that in. So I apologize, I forgot to copy and paste. Right? So what the question is asking us to do was we're trying to answer the questions whether which of the following salaries. So what we need to do, that we're going to plug in x, right? So x equal to 48 month into the surface, and then finish that. So the salary that we're going to get here
would be equal to 9.19. Remember, I had to plug in the x. So the x in this case would be 48 month plus 784.92. And when we compute this part, it would be 9.19. Simple. It's just simple as the plug-in time 48 plus 784.92. So the answer that we got is 1,226.04. Okay. And that's pretty much the thing that we need to do for question number 55. And so that's pretty much the thing. So now we're going to move on to the next part, would be called the regression model. So this is 55. Yeah, question number 55. So now we're going to go to question number 56. That will be the last question that we're going to do for this chapter. So 56. Okay, so what is the question number 56 going to ask us working on the final exam review? So the first, we want to write that ourselves with respect to the forms that we have. So I'm going to copy and paste as well. So again, that we want to write that itself with respect to the snowfall and then the temperature. Right, so it makes sense because if we have the snowfall, then the cell going to go down. If the temperature is going up, meaning that people more likely to go out in the summer than in the winters, unless that we have to do the online shopping. So it might not be working for certain companies like Amazon and eBay. So similarly, that we're going to copy and paste for the chart for this part. Right, we're not going to use all of that. So we only use part of it, right? So we're not, oh, I'm sorry. So we're not going to use all of that. So we're going to cross down this and that, this and that. I mean, we don't do that unless we analyze it in the project. So the thing that we're going to rewrite this in terms of the salary cells would be equal to, so the constants, so snowfall will be 74.59 times the snowfall times the x, as simple as that, plus this is x1 plus minus, so minus 8.75 times the y's times the temperatures, right? I'm sorry, x2 plus 8,308. So after we get the regression done, and then we're going to answer the question. So what the question is asking us? So the question is asking, predict the number of lift tickets. So also it's okay. So this is not a cell. This is the ticket. So during this Christmas week, right? So it's sort of different coming from that part that we have learned. So the thing that we have here that we need to answer is the questions where the question is asking us to do predict the cell for that part. But we don't have part B. The reason behind that because we don't have time to do all of that. So now we need to answer the questions for that. So the cell that going to be what? The cell would be equal to 74.59 times the snowfall. So the snowfall was 25 inches, and minus 8.75 times the temperature. So the temperature is 35 Fahrenheit plus 8,308. So you got to be really careful with the units because there was another questions from the homework problem. So when you have the units different, so it got to be different. So in this case, the unit is degree. In this case, the unit was Christmas. Degrees, temperatures, the total in inches. So this is in terms of inches, so we're good to go. So now we're gonna plug that into the formulas for that part, and we're gonna get the final answers, which is 74.59 times 25 minus 8.75 times 35 plus, so we have to add a 1 to 7, 8,308 And the answer that we got is 9866.5. Okay, so that would be the final answers that we have. So in this case, that the cell is literally with respect to the thing that we have. Okay, so we finish this 4. And I think I need to do one more questions about homework. Just want to be safe for that part. And what is the questions to practice final exams? So let's go to your assignment. So mind you guys are going to make mistakes on the final. So let's go to your assignments and chapter 14. And then click it's right here. So let's do for the last questions. Not the last question. Last question was simple. In terms of 1,000. Oh yeah, so did this one work for question number 12 on the homework problem? And let me just point it out real quick for that part. And I just copy and paste. Just want to be fair enough. We're gonna answer the question, these questions, and for that part. And so this is question number 12, so we need to answer it, right? So the regression model that we're going to have was the self equal to what? So the cell in this case would be equal to, with respect to the one to self, so that would be 0.76. So we look at that, the 0.76 times the house, right? Housing star. Let's say times the housing star, housing plus 1.25 times the constructions, right? Times the construction. So we know what it is. And plus 5.37. Okay, so this is the part that we need to put them down. Okay, so this is the regression that we have to do. And now all we need to do next that we're going to plug in the values for that part. So the cell that we have given from the question is 17,000. So remember, you got to be really careful when you put them down 17,000 because the unit that we have is in terms of 1,000. So when a question gives us 17,000, we have to ignore 1,000, right? You're going to take 17 only, and then we plus 1.25 times the construction as well.
0.76 in the first part.
I'm sorry?
You rewrote it as 0.75.
Oh, I'm sorry. It has some eyes problems. Yeah.
Okay.
So, so the same thing for commercial construction with 32,000. I'm sorry, 3,200. But this is the construction of unit for that is in terms of 1,000. So meaning that this guy you have to divide it by 1,000. You're gonna get the 3.2. You have to move the 0 part, right? So we gotta be really careful for a certain problem like that. So it doesn't make sense. So you have to look at that. So how is that possible that the number for X was too big and then the one to set is too small, which is 5.37? That doesn't make sense. So those numbers, they should be correlated. So this one cannot be 17,000. This one cannot be 3,200 for that. So now we're going to do the math for this. We're going to 0.76 times 17 plus 1.25 times 3.2 plus 5.37. And we're going to get the answer, which is 22.29. Okay, that's it. We finished that part. It's literally the thing that we need to answer. So the final answers for this part is 22.29. But so remember, this is in terms of 100,000. So you need to multiply this by 100,000. So this one will be 22 millions. So the correct answer for that is D. Right? So D will be the correct answers. All right. So we finished chapter 14. And remember that the relationship is basically objective. It's might be bias around, so there's no way that you cannot avoid the bias. So you have a standard error and all kind of that. We need to justify the bias by computing a p-value and then using a t-statistic. So it is not an easy chapter. So when people create the regression model, we need to justify the answer sometimes, but we did not have time to cover it. So unfortunately, so we stopped the lecture right there. So sometime when we generate, let's say, exponential model, right, to predict the COVID-19 cases for the entire New York City, actually doing a project like that, but for the students. But generally, this is not a thing that we care much about, but we need to know how to substitute them and compute and compute the y along the way. So that's gotta be careful with the units part, and that's pretty much the thing that we have with chapter 14. It's relatively easy chapter. So, but the most important thing is I'm gonna close this. I'm gonna go to the project, right? So let's go to the project and see what's going on. So I'm gonna get rid of this part because it's just the nodes. I can create the model for that correspondingly. It's not a big deal. So I'm gonna close it. Remember, when we use the x to predict the y, it's different from using the y to predict the x for the y equation. You cannot do backward for that part. So the regression can only work if we set which ones as the independent variable. So which one will be the x and which one will be the y. So gotta be really careful when you do that project. And so what we need to do was I need to go to the sample project. So this is part 3. Okay, so so for this part, so let's say I want to use for the sample project. So we want to use which one I treat this as independent. So I consider Tesla is a pretty good independent stock. So can it use Tesla to control the entire Intel market, for example? So does the Intel has something to do with the Tesla? Does the Intel depend on the Tesla stock's price? So that will be the question that we want to choose. So let's say I want to use Tesla as an independent stocks, right? Independent stocks. So what does it mean by that? So meaning that the price of the Intel basically being controlled, being dependent on the Tesla prices. So we call it X as the Tesla. So and then the other ones, Y, Intel as dependent stocks, right? Dependent stocks. Y, right? So meaning that we're trying to develop the model y equal to ax plus b. So y would be the Intel equal to a times Tesla plus a certain b, and we want to see if that regression makes sense. So we're going to box these two, right? For sure, it's literally a thing that we need to do. And instead of doing the stock, we can do the return as well. Some people interested more about the money that people, the fact that Tesla actually dropped after one single word that Elon Musk just made. They lost 100 billions on that day when he said that the Tesla stock basically it's being too high. So this is what the model looks like. So we go to insert, and then we click the scatter plot after we box them. So this is what we call the correlation of regressions between Tesla and Intel. And so this is a thing that we need to write them down. So we can use this regression model. Just want to be fair. It's not going to be really the thing that we have. So does it look like it's the linear? So assuming this is the linear model, usually that we have to do something else, but since we don't have time. And then we click trend line, right? We click the plus. And then, so for those of you who are using Mac, so we gotta be really careful. You have to look for the options on this line. It's not gonna be something like we see right here. This is when I'm using window. Okay.
Sorry, Professor, I had a quick question about this part of the project 3.
Yeah.
Is this the first question of the third? Oh, so this is so then last class. I can't remember. Did you go over project 3? Kind of.
I did. I have a sample project for part 3 for question.
Yeah. Then is this? Oh, so that one was question 2, and this one is question 1.
Yeah.
Okay, got it. Thank you.
Welcome. So for that part, that we're gonna click on displays equation on chart, and it displays the R square. So remember, the R square is something that we can compute it using the SSR and SSE. So it's just the how much that percentage that it's related. So 0.6. So 0.6 when I take the square root of 0.6. So the question is, so we only have 62% of the data set of a Tesla and Intel, they are correlated. So involving in this regression, I mean, 62% is pretty okay. That would be around 0.8 correlations R. It's pretty okay, but still not a good model to justify. So meaning that it's literally going to be linear, right? So I mean, should sooner or later that we realize the stock always have some correlation for that part, right? So when what happening when one stock going down, the other stock going to go down if there's nothing else happening in the world, right? So they should have some basic correlation for that part, but it's not as simple as we have right there. So this is what we generated for the regression model. Another way that we can do so, for example, that we can also make the regression model by going to data and data analysis. And then we go to regressions, right? And then we click OK. So we gotta be really careful by picking the correct Y and the correct X. Remember, when you pick the wrong thing, you're gonna get the wrong regression. So I want to prove this, they generate the same thing. So the Y that I'm gonna pick the Intel. So I treat the Y as the Intel. And the X, so I'm gonna treat this as Tesla, right? And let's go down right there. So they both know I want to get the output range. I want to have all of the data set generated on this chart here. Okay, so this is a thing that we need to do. Do we need to care about the residuals plot? The answer is doesn't matter. Line fit plot. Yes. So let's click on it and see what it is. It's included numerical values, meaning that we cannot start from S5, so we start from S6. And this one X6, so we cannot use the X value. I mean, we don't pick the label, but anyhow. And then we click OK, so this is gonna be the thing that we have for the model. And this is what it looks like for the line. And it's pretty much the same thing that we have right there, except for the fact that, I mean, it looks the same thing, but this is more like statistics. This more like the playing around is not a statistic, but it still be a statistic, but not as cool as the thing that we have right there. So we can see that the regression that we have is X, the Tesla. So I can rewrite the Teslas with respect to 0.02, I'm sorry, Intel 0.027723 times the Tesla and plus the one to set, which is 42.96793. That's pretty much the same thing that we have right there. 0.0277x plus 42.968. So this one is more accurate. 96793 is actually give us up to like 5 decimal points. And for this part, only give us 4 decimal point. I mean, we can fix that, but generally, this is not so important. So both of them going to give us the same answers for that part. So generally, all we need to do on the project part 3 is that we're going to put it down. I mean, it doesn't matter about the order that we need to do. So this is, let's say this is the first, this is the second question, and now this is the first question. So what we need to do is that I'm going to copy and paste for the model, and this is the thing that we're going to copy it down and put it on the Word file. So remember that we didn't change it. So I think I'm missing a typo for that. So so this is the part that we're going to put down the curve. And finally, that we're going to we're going to copy and paste for the table, and then the ANOVA table is actually more important. So this is what we have for for the regression model. So we're gonna copy and paste. So using that table, what can you tell us? So the R square is relatively not too big. So what does the R square going to tell us? So when it come back to the project part 3, when you go up there, and then we can see that the project part 3 is going to give us some points. And so let's go to that part. So you need to answer the question: if the correlation is significant, what does this imply about a trend? So how do you know if the correlation is significant or not significant? So we need to look at the correlations in terms of um, the p-value. So the p-value correlations in this case, that is for both of them, is relatively small. So the p-value is small, then good enough, right? So we can just justify the answers by looking at the p-values. So the p-value was relatively small. So the p-value is relatively small. So meaning that it is significant. And if the p-value is really big, then we cannot say anything for that. So after we conclude that this is significant, so meaning that it's good, it is good to predict, to use the Tesla stock, to use Tesla stock price and predict the Intel stock price. So as simple as we have right there. So sometime we want to make this a little bigger so you can see what it is. So the thing that we need to do was the big p-value, meaning that if the p-value is big enough, then it's not working out. It's not working out generally. So the p-value is smaller, meaning that, well, it's good to use when the p-value is big enough that it can use the t-statistics. So it is actually help us test it. But we're not going to cover this chapter because of the fact that we do not have time. So I might want to copy this and post it on Word file. Just want to make sure that I'm not going to write something too much for that part. And so we want to use Tesla's price, Tesla prices, stock price, as an independent stock X, and Intel prices. I mean, you can do for return, but the return you have to subtract Y1. So previous prime minus whatever, so it's too much for that. So stock, it should be good enough. I mean, some people don't care about the prices, they care about how much money that they make and whether or not they generate a positive return at the same time. So that's more interesting somehow. But in this case, that we only look at the prices. So unfortunately, we don't have time. So, and after that, and we're gonna answer the part B. What is find the equation? So the equation is right there. So I just write down. So the equation will be 0.00. We can see the equation right there as well. We can copy and paste. And what is the R square? So the R square is what? So interpret the meaning of R square and then adjust this R square. So we don't adjust this R square when we actually consider a different part for that part. But what is the meaning for that? So the meaning for that is so the meaning so the regression model, the regressions model is a positive line, the linear regression models, right? And a positive slope regression model and regression model. So what does that tell you if we have a positive slope? Meaning that if Tesla's price go up by once, so it's really big deal. So if Tesla go up, the stock price Tesla go up by 100, the Intel go up by $2. So that's going to be a big difference. You can see that the risk that Tesla faces compared to the Intel by looking at the regression is really, really big, right? So if the Tesla price go up by 1, the Intel price go up by the Intel goes up by 0.027723 dollars, right? And so this is the thing that we need to take care of that. And so this is so important. When the Tesla prices go up by 100, then the Intel price go up by $2. So that's basically nothing, but still be a good relationship for that. When we try to consider that. And finally, interpret the meaning of R squared. So we ignore the adjustments of R squared. So the R squared that we computed, is what? So the R squared that we computed is what is 0.6261, 0.6261. So means that 62.61% of the stock price of two company stock prices are involving in the regressions. So meaning that there will be around 38% of the stock prices basically not correlated that much with the regression models involving in the regression model. And that's pretty much the thing that we need to do. And the final questions, based upon the line, so what is the best values? I'm gonna leave it for you guys to explain it. So can I use the last past data set like 2 years ago to predict nowadays prices? No, right? So the regressions models, what is the point of doing that? So we want to predict the next week, right? So the next week regression model. So can we predict the prices at next year, so that'd be 2021 using the same model right here that we have? The answer is no, right? So we need to justify that. The best predictive values. What is the best predictive values, right? So the best predictive value is basically the most recent values, right? And so best predictive value for Intel, right? So what can we conclude that? So we need to justify these answers using your reasoning, right? So similarly, if it tells you that 10 days later the weather going to be extremely hot, would you believe so? The answer is that will be less accurate if it tells you that tomorrow the weather will be hot, because the next day going to generate the better predictions. If the data set going, if you want to predict something that is too far away from our data set, so that no longer become accurate. So that's a reason why when we see people actually working on the predictions on the cases, on the data sets, on the prices, on the stock, they use the spontaneous prices, the most recent prices to predict the next one. So that would be the more accurate information that we can justify. So anyhow, so we're gonna have finished. I'm not gonna write down the last questions, is the point. So we need to explain biological reasoning. And so we need to, this one is simple, that if the price go up by 1, the slope is telling you how much that the y going to go up according to the x, okay? So that's pretty much it. So when we come back on, so that's finished for project number 3. When we come back on Thursday, so we're gonna have the final exam review. And we come back on next Tuesday, there will be another final exam review. And that's gonna be the thing that we need to do. And then we're gonna take the final exam on next Thursday. That'll be on May 20. I'm sorry, May 14, I'm sorry. Yeah, so that's pretty much it. So there'll be the quiz number 5. Quiz number 5. The quiz number 5 will be changed. Remember that. So the quiz number 5, you're gonna go to the quiz, and then you're gonna have until until 9 p.m. to finish it. So okay, so the quiz, I'm gonna change that. So the quiz number 5 will be on chapter 12. So that will be on the thing that we just learned next Thursday. So that will be on independent test. Okay, so I'm gonna give you the table, maybe 2 by 2 or 3 by 3 or 3 by 2. That easier, so you can do the math for that part, and you test whether or not it is dependent. Okay, so we cannot check if they're independent, but we can check if they are dependent for that part. Okay, so remember that we please make sure that we do the quiz number 5 right there, and then you can resubmit the work along the way. So I'm gonna get rid of this file, and we're gonna add a new one. So I apologize for if some of you actually completed, but please, I'm gonna restore the quiz number 5, and that's pretty much it. So this will be the last quiz that we have for the semester. Yeah,
Is it still going to be open tonight and due tomorrow?
until Wednesday at 9 p.m. tomorrow.
So like we should wait till like 8:30 or 9 to
Yeah, and then you can get it done. So it can start tomorrow morning if you want.
Oh, so wait, so is it going to be posted tonight or tomorrow morning?
Tomorrow night.
No, I'm saying, are you going to post the file for us to open tonight or tomorrow?
Tonight at around 8:30 to 9 p.m.
Okay.
Okay, so we have the whole day to do so. So make sure that you do the quiz, and that's pretty much things. Okay, so take care for all of you, and I will see you guys back on Thursday for the final exam review.
Thank you.
You're welcome.